Our goal today is to be able to find both the area and the perimeter of composite shapes. Now, when I say composite shapes, I mean shapes that are made up of other shapes. So you might see a shape that's made up of several rectangles, or a rectangle and a triangle, or a rectangle and a triangle, and maybe a parallelogram. So we're going to review a few things from when you were in elementary school. But as sixth graders, we're going to work on writing equations to represent the area and perimeter. And then later on today, we're going to find areas and perimeters of some more complex or some more composite shapes. So the first vocabulary word that we need to go over is perimeter. And if we look at this, we have the smaller word rim in here. So if you're thinking about perimeter, you want to think about the distance around a figure. So if I draw a rectangle here, my perimeter is going to be the distance around this shape. Will you show me a hand motion that helps you remember what perimeter is? I see some of you drawing rectangles in the air. Oh, some of you have circles. That's called circumference for circle. That has a special name. Some of you are drawing triangles. Perfect. The next word that we have is area. And it is the amount of surface inside a figure. So if here's my same rectangle, well, a little different. It would be the measure inside of the figure, okay? You can also think of like an area rug, and you think about how much of the floor it covers. One more thing, crew. When we talk about perimeter, we give our answer in terms of units. And when we talk about area, we give our answer in square. I'm going to abbreviate square to SQ, square units. And I'll make sure to label things as we're working through. Okay, so the first problem we have asks us to find the area of a rectangle. We've also been told that this is the product of its length and width. Product lets us know that we are multiplying. Okay, remember I told you we're going to work really hard on using our equations. So if we say area equals length times width, okay, our length is 6 and our width is 4. So when I come over here and I write my area is equal to my length of 6 times my width of 4. So my area here is equal to 24 centimeters square. And my units in this case are centimeters. Okay, do you see how each one of these pieces in here is made up of squares? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yes, Michaela?
Why don't you add up both of the 6's and then add up both of the 4's and then multiply them together?
Add up both of the 6's and then add up both of the 4's and then multiply them together.
Yes.
Because in that case, we wouldn't be finding 2 dimensions, we'd be finding more dimensions than 2. Sometimes you might have heard of multiplying the length times the width times the height, and that's volume instead. But we only need 2 dimensions, so we're multiplying 1 dimension of our length times our width. You might also have seen your answer written as 24 centimeters squared. Okay, that means the same thing as square centimeters. I just think it's easier to think about what a square centimeter is. All right, the next one we're going to look at is our perimeter. And in this case, it was written as length plus length, width plus width. During our warm-up today, we saw a couple of different ways that we could choose to write that. So we have 6 plus 6 plus 4 plus 4. Okay. Both of my lengths added up together is 12. Plus both of our widths added up together is 8. So we have a perimeter of 20 centimeters, okay? Perimeter is just in one dimension, so we just say centimeters, not square centimeters or cube centimeters like we would for volume. All right, is it all coming back to you? Yes? So our next one we have, use the area model to find the area of the rectangle to the left. Hopefully you just made a connection between, oh my gosh, we've been multiplying mixed numbers for weeks. And basically what we're doing is we are finding the area of something. So if I use what we talked about before to find the area is our length times our width. So we can say that our area equals our length of 2.5 times our width of 3 1/4. Okay, we can use this fancy area model that we worked so hard on. Part of it is done for us. 2 times 3 is 6. 1/2 times 3 is 1.5. 2 times 1/4, or 2 groups of 1/4, is 1/2. 1/2 times 1/4 is 1/8. Okay, now just like we were talking about before, we're going to add all those together. 6 plus 1.5 plus 1/2 plus 1/8. Now in this instance, I don't need to find a common denominator. I'm going to show you why.
Crazy.
If I add together 1.5
That's 2.
and half, I get 2.
Oh.
So I can say 6 plus 2 plus 1/8 is equal to 8. And 1/8, what's our unit?
Centimeters.
Centimeters. Yeah. And those two little lines right here, guys,
It's inches.
those mean inches.
Oh, so it's inches.
So I'm going to say square inches. Square inches.
Square is what?
What's it? Okay. Let's find the perimeter. Why don't you see some of you doing your hand motions? You're so fun. So perimeter equals our length, that's my L for length, plus width, okay, which is also equal to, I can use my equal sign again, because this will be equal to what I wrote before. 2.5 plus 2.5 plus 3 1/4 plus 3 1/4. Okay, I just added up all my sides. So 2.5, 2.5, 3 1/4, 3 1/4. I'm going to add 2.5 plus 2.5, which is what, crew?
5.
And now I'm going to add together 3 1/4. Oops, I'm in a different color. 3 1/4 plus 3 1/4. What would that be? 6.5. Add those together. What would I have?
11.5.
I would have 11 1/2. What's my unit?
Inches.
Just inches. Yep. You could also write 11.5, 11 and 5/10 if you wanted to as well. Okay. Now let's get into those complex or composite figures we were talking about. We're going to start with the perimeter. And this one, I have given you some of your sides, and I have left some of them blank. Now, when you're finding perimeter, if they are blank, you still have to find them. Okay? Yes? Oh, can I go over it with you guys? Just because for some kids, this is the first time they've seen it. Thank you, but will you check my work as I'm going through it? Thank you. Okay, so I am missing X and I am missing Y. I'm going to start by finding X. So I know that the length of this side right here that I'm drawing is 5, which means that this section plus this section plus this section all have to go together to be 5. So 1 plus something plus 2 has to be 5. So Jackson, what did you get for x? 2, okay? So that's what will make these sections equal to each other. Okay, now here's your next one. I'm going to show you one way, but this is not the only way to do it. There's lots of ways you could choose to do it. But I'm trying to find this distance of y right here. Okay, I want to know what y is. So, one of many ways that you could choose to solve this. If I know that this entire length right here is 4, okay, I'm going to use that to help me out here. I also know that this length right here is 3. So that means that this portion right here from there to there, what does that have to be? 1. It has to be 1. Okay. And then this little piece down here is also 1. So if I add together this 1 centimeter here, plus this centimeter here, which is the distance from here to here, that is the same as, oh, it's all stuck together. I don't want them to stick together. That's okay, we'll live. They're the same as this distance here, right? There we go, I can move that one. Do you see how those are the same?
Yeah.
So that means what is y?
2.
Y is 2. Okay, now I just told you that's one way that we might choose to solve this. It's definitely not the only way, but it's just one way that we might choose to do it. Okay. So now we need to add up all of our sides. And remember, the hardest part about perimeter is making sure that you add up all of your sides, okay, that you don't forget any of them. So this one, we started with the 2 right here. And then we had 4. And then we had 5. 3. 1. 1, x, which we knew was 2, and then y, which we also found was 2. Okay, add all those together. 2 plus 4 is 6, 11, so plus 5 is 11, plus 3 is
14.
plus 1,
15.
plus another one,
16.
plus 2,
18.
plus 22,
20. Yeah.
so we have 20 centimeters. And because it's perimeter, we're going to leave it at 20 centimeters. Okay, now here comes the area of this shape. This is one of 2 strategies that you might see. When you're an 8th grader, we expand this to be able to find the area of triangles that are on grids. So when I do this, okay, my first strategy that I like to use is to break this up into shapes that I know how to find the area of. So far, I know how to find the area of squares and rectangles. So if I were to split this shape up this way, I have a square, a rectangle, and another square. So that's one way I could break it up and then find the area that way. Or I can break it up this way and have a rectangle, a square, and another rectangle. So let's do it that way. So I'm going to start with this section up here. Okay, this one that has the diagonal lines. I have a little diagram of it over here. So my area equals, and you're going to need to add in some parentheses on your note catcher right now. This is 1 times 3, okay? So length times width of that section, 1 times 3. I'm going to add it to my next section here, okay? Now, yes, I do have 5 right here, but that's the distance of this whole side right here, okay? Not just that section. So I have to make sure that I only do the part that I am looking at. So I found out before from my work before that this side length right here is 2. And then if I look up at my previous example, if I knew that the whole length at the bottom was 4, and I knew that y was 2, that means that this remaining piece right here also has to be 2. Sorry, 2 times 2. I'm going to find the area of this large one at the bottom. Okay, I was given the dimensions for that one. And I have 2 times 4. Okay, so let's clean this up. 1 times 3 is?
3.
2 times 2 is?
4.
2 times 4 is?
8.
Okay. When I add all those together, what am I going to get?
15.
So I have 15. What's my label?
7 squared.
7 meters squared because I am doing area. Okay, so that's one strategy to break it up into other shapes. Flip to your next page, please. Okay. My next strategy is to take my shape and to turn it into a rectangle. Okay, so to surround my rectangle. Okay. And then I'm going to look at this leftover part. Let me make this a little bit more precise. I'm going to look at my leftover part, and I'm going to subtract that. So in all, this whole big rectangle that I have has the dimensions of 5 times 4. And from this, I want to subtract out all of those extra pieces. So I want to start with this portion right here, okay, which in this diagram is this part right here. So I'm going to subtract it because it's not actually there. And looking at my previous page, I can see that my dimensions of this, okay, if I look at X and Y, those were 2 by 2. Okay, so this is where X was and this is where Y was. So it's 2 by 2. Okay, so the area of that I'll subtract out. Minus my last one, which is this little piece up here. Okay, which if I go back to my previous page, I can see from this picture here that it is 1 by 1. So I'm going to subtract out that little piece as well. Okay, so I have 20, which was the whole thing. 4 minus 4, thank you, minus 1.
Equals
Which is
15
centimeters.
centimeters.
16 minus 1, which equals,
Centimeters squared.
which is what we got last time too. So you have 2 ways to solve your problem. All right, from here I'm going to give you a little bit of time to practice the next couple of questions, and then we'll finish talking about this on Monday.